Okay, let's look at some of your homework problems that we have in this section. Let's start off with this problem here. We're trying to find the complementary angle, and we've got an angle here that is in degree, minute, and seconds. So here's what you do. Well, first of all, we want to find the complement of this angle. So basically, we're going to do 90 degrees, 0 minutes, and 0 seconds, and we're going to subtract 38 degrees, 28 minutes, and 20 seconds. So this is kind of just like borrowing when you're actually subtracting stuff. Here I've got 90, 0, and 0, and I'm going to subtract 38, 28, and 20. Now, in order to subtract 20 from 0, I have to borrow from over here. I've got nothing to borrow over here, so I'm going to go over here to 90. I'm going to make this 89 minutes, 89 degrees, and 60 minutes. And then I'm going to borrow a minute over here. I'm going to make this 59 minutes, and I'm going to make this 60 seconds. So 60 seconds is a minute. Add another minute to this. That adds to 89 is degree. So this is actually still 90 degrees. And now I can just go ahead and subtract. 60 minus 20 is going to give me 40. 59 minus 28. I'm going to do 59 minus 28. I'm going to get 31. And then 89 minus 38. And that's going to give me 51. And so that should be my answer that I have. Okay. Now to find the supplementary angle, I'll let you guys do that. But you start off with 180 degrees, and then we're going to subtract 38, 28, and 20. So we're going to borrow a degree from here. We're going to do 179. We'll make this 60, but then we're actually going to borrow and make this 60 over here, and then make this 59, and then go ahead and subtract and get your answer for the supplementary part. All right, let's look at a couple more homework problems. Here we want to find the 6 trig functions that go with this angle alpha. We can see that this angle goes down here. So here we have our points. And if we look at what this looks like as an actual triangle, we've got our y-axis, we've got our x-axis, we've got the 0.7, -2, and then we've got alpha here. So I'm going to draw a right triangle. This is a length of 7 here. We'll call this -2 over here. We can figure out sine of alpha is equal to the opposite over the hypotenuse. So now we got to figure out what the hypotenuse is. So that's going to be the square root of 7 squared plus 2 squared. So that's going to be square root of 49 plus 4. That's going to be equal to square root of 53. And that's going to be the length of our radius. So the sine is going to be equal to the opposite over the hypotenuse, which is going to be equal to 2 root 53 over root 53. And then you go through all 6 trig functions that way. Let's look at this problem that we have here. We're given that the cosine of phi is equal to -7 over 25, and we're told that it's in quadrant 2. So here we have our triangle. We know that it's in quadrant 2. It doesn't really matter how you draw the triangle. Here's our angle phi. Here's my point. And we know that cosine is equal to the adjacent over the hypotenuse. And we're given a value of -7 over 25. So I'm going to write -7 here. I'm going to write 25 up here. Now I have to figure out what sine is using my Pythagorean theorem. I know that 25 squared is equal to minus 7 squared plus whatever this is squared. So I'm going to do the square root, and I'm going to do 25 squared minus 7 squared, and that's going to give me 24. So now, once we figure out the side, we can figure out that the sine of phi is equal to 24 over 25. The tangent of phi is equal to 24 over minus 7, and so on and so forth. Let's look at this one here. Here we have the cosecant of 407 degrees. Now, cosecant is 1 over sine. This is just a calculator problem. I'm going to make sure that I'm in degree mode. So I'm going to go back to my mode. That's right here. I'm going to check to make sure that I'm in degrees. And I'm going to do 1 divided by sine of 407. I'm going to get 1.3673. Okay. Sorry. All right. This interval part that we have over here, that just tells you what quadrant that it's going to be in. So this one's going to be in quadrant 4. I know that cosine is positive and sine is going to be negative. Here I have the sine value as negative. But to figure out what this angle is, you've got the fact that sine theta is equal to negative 0.9336. So to figure out what theta is, I want to use inverse sine. A little bit of glare here. Fix that. And let's use the autofocus here. Okay, so now I'm going to clear that out. I'm going to do second sine, and I'm going to type in negative 0.9336. Let's see if we can, actually, let's try, I apologize for this, having technical difficulties, obviously, but what I typed in to my calculator is exact. I typed in this to the calculator. I did sine -1 of negative 0.9336. I'm going to press enter, and I'm going to get negative 69 I'm going to get negative 69 degrees. Now, we can't type in negative 69 degrees. We have to use a positive value. So I want to figure out what this is. So I'm going to do 360 minus 69. I'm going to get 291. And that should be my answer for this problem. Okay. Last one. Let's look at navigational bearings. I'm giving you one question like this. Here I have a plane. It starts at an airport and flies. where it is a direction of 200 degrees from true north. If you take the axes that we're using before and you flipped it across the y equals x line, and then your navigational bearings become your regular trigonometric bearings when we use on the circle. All you're really doing here is looking at a triangle. This is 120, and we want to figure out how far west of this is the airplane. Oh no. So the plane actually flies 120 here. So we want to find out this part here, and we want to find out this part here, and we know that this is equal to 200 degrees. Okay. Well, I know it's 180 to here, so I know that it's another 30, another 20 degrees to here. That means that this angle here is going to be 70 degrees. We're using our supplements and complements to actually figure out what angle this is on the triangle. So again, this part here is 200 degrees. So it's 180 to here. That means that there's 20 left over here. That means that there's 70 left over here. So anyway, so what triangle we're actually looking at is this is 120, this is 70 degrees, this is an angle here. So this actually goes back to what we learned in section 6.1. I want to find these two values. So I'm given this angle, I want to find x. That is the adjacent and the hypotenuse. So the cosine of 70 is equal to x over 120, or 120 times the cosine of 70 is equal to x. And then for y, that is the opposite side. So I'm going to write sine of 70 is equal to y over 120, or 120 sine of 70 is equal to y. And then you just plug those into your calculator and you'll get your answer for this problem. All right, that should be it. Good luck with this section.